Moving on to 1.2, we have data and distributions. What we're going to look at is two graphs that can show a distribution of a data set. And we're going to look at two different types of data. We're going to look one as categorical and one is going to be quantitative data. So what a distribution is. A distribution is showing us how the data is spread out. Shows a pattern of variation within the categories of a study. And it's going to be categories, or if it's numerical data, it's just going to be where do the numbers fall. Okay? So the distribution is, here's all of our information, how's it spread out? High numbers, low numbers, does one category have a lot more than the other categories? That's what we're going to look at. Bar graph is a good way to look at categorical data. I'm sure bar graphs is something that you've been putting together for a long time, thinking back to elementary school. You have your set of values and you're putting them into certain categories, whatever the situation is that you're looking at. Okay? Good example here is this is pets on the street. We have a count going on the y-axis here. How many dogs are there, cats, hamsters going across. I want to point out the gaps in between our categories there. Okay? Another example here, this is a ice cream eating contest. So we have the contestants down here by name and the number of scoops. Again, another count. Okay? So this is showing how many scoops each person ate. And again, the gaps in between. That is important. Okay? This is categorical data. Every category is separate from the next. Each contestant is separate from the next. It's not continuous. Same thing here for the types of pets. The pets, once the dog stops, the cats are a completely different category. It's not continuous. So classes are not connected, and this shows that they are not by not connecting the bars. The classes are different from each other, and that's the important part of a bar graph. Now, both these two bar graphs showed counts. Okay, we counted up the y-axis. Another one, or a type of bar graph, this is a proportion bar graph, and it's going up by proportions on here. Okay, and each category here, we're looking at how people feel about math. We have men and women over there. Red is the women, the blue is the men, and the categories here is how they feel. Okay, and each one of these, this is showing the proportion of men and women, how they feel, how many strongly agree, and shows how it's different, okay, between the men and the women. Each category is separate from each other, but together they're touching here because in a whole, this is making the whole group that fell into that category of strongly agree. And if you look at each bar, here we have about 42%, this is about 58%. Add them up, you get 100%. Or even down here, we're looking at that one, that's probably about 18% or so, compared to 82 for the female, the red bar. Every section is adding up to 100%. So a lot of times you have to do a little bit of math to figure out what your proportions are. Okay, so let's put one together. Okay, so here's our question. Construct a bar graph for the proportion of people in favor versus not in favor of abolishing the penny, comparing males and females. So here's a little chart you could use to put this together. So I did this before in my class, and these are the numbers that I ended up with. Okay, we had males 4, 13, males against 7. Females 4, 10, females against 10. Okay, so there's the numbers that we came up with for that situation. Now, first thing I'm going to do when I'm putting this together, I'm going to X, Y axes, and this is one I'd ask my class to do this quickly. Okay, you don't need to take a ruler. We don't need a perfect vertical line, horizontal line, as long as it's neat enough for us to see. We know we have our y-axis, and up there we're going to have our proportions. Okay, so I'm just going to put a percent sign. Maybe I'll put it as percent. So let's do 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That last example I had it in proportions with the decimals. I just want to have mine as percent. Okay, down here we're going to have males, and we're going to have females. Okay, so let's label this, make sure people know. I mean, we're talking about males, females. I know it's kind of obvious, but let's put it as gender so we know what we're looking at there. Now we're also going to have a little key. So we're looking at males for, males against. So I'm going to have a blank, and that's what I'm going to count for the for, abolishing the penny. Over here I'm going to have, fill that in for a solid. That's going to be who I think is against Okay, abolishing the penny. And let's just label this real quick. When I'm asking for labels, titles, something quick. I have percent sign here, gender here. Let's just call this whole graph penny. Okay, that's what we're looking at. So before we can start doing up our bars, we need to find the proportions. We're not going by count. We're not going up 13 compared to 7. I want to look at the percentage difference. So for each one of these, I need to do the total. So remember that let me get a different color here. The males and females, we're looking at them as two separate categories. The males, and that's a total of 13 and 7, gives us 20. So to get our proportions for this one, we're going to do 13 divided by 20, and that's ended up giving us a 65%. Now you can just use the complement. We know it has to be a total of 100%, or if you just want to do the math real quick, 7 divided by 20, 35%. So that's going to be our bars for the males and for the males, for and against. For the females, 10 and 10. This one works out a little nicer. Okay, we should be able to look at 10 and 10 gives us 20. 10 divided by 20. That one should be an easy proportion. That's going to be 50%. And if 1 is 50%, that means the against is also 50%. So just doing a little bit of mental math there. So if I do these bars for the males, 4, this is going to be our clear bar here. I'm going to go up to about 65, and you don't need to take out a ruler and measure it, just estimate, okay? That's between 60 and 70%. There's our 65. For the 35%, fill it in there, and again, I'm not looking for, if you want to make it nice and fancy, go for it. But if not, and now you're seeing the difference. How many males are for getting rid of the penny? How many males are against it? Now the females, 50-50, both those are going to go up to 50%, then 50% for against. Fill out that bar. Okay? So that's basically what I need for a proportion bar graph. Now, what you would ask to do now is describe what you see. Okay, and what I'm seeing is that females are pretty split, right down the middle, 50-50%. If our sample is a good sample, the females, some are for keeping the penny, some are against it. For the males, there's a lot more for getting rid of the penny. Okay, we have 65 compared to 35. Use the language of linkage, compare. Don't just list your numbers. Say that we have a large proportion of males for getting rid of the penny compared to the 65 is greater than the 35% who are against getting rid of the penny. Okay? This was categorical data. Okay? You either were for or against. You fell in one of those two categories. The second half of 1.2 is I'll look at quantitative data.